January 22, 1945, Hill 170, near Kangaw, Burma. Before sunrise, Lieutenant Colonel Simon Trevor of M1 Commando stood on the northern slope, peering into the dark edge of the jungle. 24 men were positioned around him in shallow forward defenses. Each carried the same rifle slung across his chest, the American M1 Garand. The weapon had accompanied them since the North African campaign 2 years earlier, and unlike most British formations, they had grown accustomed to its weight, balance, and rhythm. Trevor had no indication that within an hour and a half, roughly 300 Japanese troops would storm directly toward his line in a desperate frontal attack. He could not yet calculate that his small detachment would be outnumbered by more than 12 to 1. What he did understand, and what his men understood equally well, was that their rifles gave them a decisive edge in sustained fire. In a defensive fight, that advantage could determine whether a unit held its ground or disappeared entirely. A metallic action slid into place somewhere along the line, cutting through the damp morning air. The sound differed from the sharp, familiar motion of a Lee-Enfield bolt. It was quicker, more fluid, the mechanical signature of a self-loading rifle. In trained hands, the M1 Garand could deliver approximately 24 carefully aimed shots per minute. Even the highly regarded Lee-Enfield, widely considered the fastest bolt-action rifle of the war, typically managed around 15 rounds per minute under ideal circumstances. The comparison was stark. One soldier armed with a Garand could sustain a volume of fire roughly equivalent to 1.5 riflemen equipped with bolt-action Enfields. Marginal technical improvement, but of measurable battlefield consequence, fewer casualties among defenders, greater pressure on attackers, and engagements decided by seconds. The origins of that advantage trace back decades before the war, not to a battlefield, but to a workshop bench. January 1, 1888, Saint-Rémy, Quebec, Canada. John Garand was born on a modest farm south of Montreal. His early years offered little hint that he would one day design the rifle General George S. Patton would later describe as the greatest battle implement ever devised, when Garand was still a boy. His family relocated to Connecticut after his father left farming to work in a textile mill. By the age of 12, Garand himself was employed sweeping factory floors, yet the machinery surrounding him proved more influential than the work itself. He studied looms, engines, and gearing systems during spare moments, developing a fascination with mechanical precision. By 18, he had become a machinist, eventually specializing in toolmaking and gauge production, trades that demanded both exact measurement and disciplined craftsmanship. Largely self-taught, Garand supplemented his experience with correspondence courses in engineering, building a technical education outside formal institutions. In 1916, at 28, he began focusing on firearm design. 2 years later, he submitted a semi-automatic rifle concept to the U.S. Navy. The proposal impressed officials enough to secure him work at the Bureau of Standards in Washington, D.C. After roughly 18 months, he accepted a position at Springfield Armory in Massachusetts as a design engineer. What he encountered there revealed a structural weakness in American arms production. During the war, Springfield produced about 265,000 rifles, with an additional 47,000 manufactured at Rock Island Arsenal, insufficient numbers for an army that expanded from roughly 200,000 to 4 million personnel. To fill the gap, American troops were issued large quantities of Patton 1917 Enfield rifles built domestically under British license by Remington and Winchester. Garand recognized that future conflicts would not allow for slow, artisan-style production. Industrial warfare demanded firearms designed for rapid mass manufacture by semi-skilled workers using modern machine tools. He concluded that the decisive advantage would belong to the nation capable of equipping its forces quickly with weapons that maximized individual firepower. His vision centered on a rifle that would chamber each successive round automatically after the trigger was pulled, eliminating the need to manually cycle a bolt. A semi-automatic system would significantly increase practical rate of fire, allow the shooter to maintain aim between shots, and shift the tactical balance in favor of units able to deliver sustained, accurate fire. The path to that outcome involved experimentation and setbacks. Garand's earliest prototypes relied on primer-actuated mechanisms, using the energy of the cartridge's primer to operate the action. The approach proved inconsistent. He ultimately abandoned it in favor of a gas-operated system, diverting a portion of propellant gases from the fired cartridge to cycle the mechanism reliably. From those technical decisions would emerge the standard-issue semi-automatic rifle that set the United States apart from every other major power of the Second World War, and reshaped infantry combat in the process. The existing .30-06 Springfield cartridge, rather than the newer .276 Peterson round for which it had originally been engineered. His decision was driven by logistics and cost. The Army already possessed vast reserves of .306 ammunition, and transitioning to a new caliber would have required substantial funding and years of delay. Garand returned to the drawing board. Converting the rifle to handle the more powerful .30-06 round required a major redesign, not minor adjustments. The work consumed roughly 3 years. On August 3, 1933, the updated weapon received its official designation, United States Rifle, caliber .30 M1. It was formally adopted as the Army's standard infantry rifle on January 9, 1936. The first production example successfully completed proof, function, and accuracy testing on July 21, 1937. Initial manufacturing was modest. In September 1937, Springfield Armory turned out only about 10 rifles per day. By early 1940, output had risen to 100 daily, still insufficient as tensions escalated overseas. In September 1939, the same month Germany invaded Poland, Winchester Repeating Arms Company received a contract to produce the M1. Company officials were skeptical. Many engineers regarded the rifle as overly intricate and costly to build. Cooperation between Winchester and Springfield was strained, with each side criticizing the other's methods. Nevertheless, production expanded as the likelihood of American involvement in the war increased. After Japan attacked Pearl Harbor on December 7, 1941, rifle production became an urgent national priority. By January 1942, Springfield was producing more than 1,000 rifles per day. By the war's end in August 1945, total M1 production exceeded 4 million units. The United States stood alone among major powers in equipping its infantry primarily with a semi-automatic rifle. British, German, Soviet, Japanese, and Italian forces largely relied on bolt-action designs. This distinction had major battlefield consequences. Operating a bolt-action rifle required a sequence of deliberate motions between shots, lifting and drawing back the boat to eject the spent casing, pushing it forward to chamber a new round, locking it down, and reacquiring the target. Even for a trained soldier, this cycle typically took several seconds and longer under fire. The M1 functioned differently. Gas pressure from the fired cartridge automatically cycled the action, ejecting the spent case and loading the next round. The shooter maintained position and sight alignment while firing successive shots in rapid succession. A single round required no less time than a bolt-action shot, but sustained fire revealed the advantage. An M1 rifleman could deliver 8 carefully aimed shots in about 20 seconds. Comparable British or German bolt-action rifles required roughly twice as long for the same output. In combat, that difference translated into overwhelming fire superiority. American infantry units could project substantially more accurate fire, suppress enemy positions more effectively, and disrupt assaults before they gained momentum. The rifle was not without flaws. Its 8-round N-block clip system prevented simple topping off during partial use. Soldiers either expended the full clip or manually ejected it, potentially discarding remaining cartridges. The sharp metallic sound produced when an empty clip was expelled became widely discussed, though whether it was tactically significant remains debated. Marches, the additional burden was felt. Despite these drawbacks, the rifle's strengths dominated. It was durable, reliable in adverse conditions, and effective at ranges approaching 500 yards. The .30 Alt-6 cartridge provided substantial stopping power. Most importantly, the weapon delivered high-volume, accurate fire to every infantryman. The British Army examined the M1 in 1939 as a potential successor to its standard rifle. However, by early 1940, domestic manufacturers were already preparing large-scale production of the Lee-Enfield No. 4. British planners concluded that shifting to an entirely new system would disrupt output at a critical moment, especially with the threat of German invasion looming. Cost was another factor. By 1943, the M1 cost approximately $85 per unit, roughly $1,400 in today's currency, almost twice the price of a typical bolt-action rifle. For a nation under severe financial and industrial strain, such an expense was difficult to justify. In the end, the M1 Garand reshaped infantry warfare for the United States. While others held to older designs, American forces entered the Second World War equipped with a rifle that combined reliability, power, and unprecedented sustained fire capability. In the years before the Second World War, Britain confronted a practical obstacle when considering newer semi-automatic rifles: ammunition compatibility. The American .0606 Springfield cartridge could not be used in rifles chambered for the .033 British round. Switching to a rifle like the M1 Garand would have forced Britain either to retool ammunition production on a massive scale or to redesign the weapon entirely, both options costly and disruptive. Its magazine held 10 rounds, double the capacity of most other bolt-action service rifles of the era, and it could be replenished rapidly using 2 5-round stripper clips. More significant was the rifle's remarkably fluid bolt mechanism. Unlike Mauser Patton systems that locked at the front and required a long upward bolt lift, the Lee-Enfield used rear locking lugs and a shorter bolt throw. This allowed the action to cycle with minimal disturbance to the shooter's aim. In practiced hands, the rifle could be fired and reloaded without ever leaving the shoulder. British training emphasized this capability. Soldiers were required to pass the famous Mad Minute qualification. Beginning with a loaded chamber and 4 rounds in the magazine, a rifleman had 60 seconds to fire at a target 300 yards away. The target consisted of a 4-foot square frame with a 12-inch silhouette at its center. Ammunition had to be drawn from pouches during the drill, not prepared in advance. 15 hits were required to qualify, yet experienced marksmen often delivered 20 to 30. Exceptional shooters surpassed 35. In 1908, Sergeant Major Jesse Wallingford recorded 36 hits, and Sergeant Instructor Frank Snooksel was later credited, though not conclusively, with 38. Such results reflected relentless training and the professionalism of Britain's pre-war volunteer army. When the British Expeditionary Force met German troops at the Battle of Mons in August 1914, German soldiers reportedly believed they were facing machine guns. In reality, they were confronting disciplined riflemen armed with Lee-Enfields, or more accurate shots per minute were attainable. The arithmetic was revealing. 3 British riflemen firing 15 aimed rounds per minute each produced a combined total similar to that of a single American with a Garand. Moreover, the semi-automatic shooter retained a continuous sight picture. Without the need to manually cycle a bolt after every shot, he could maintain position, track moving targets, and deliver sustained fire with fewer interruptions. Even fractions of a second mattered in combat. Fully equipped American units began arriving in the Pacific late in 1941. The Philippine Department received shipments of Garands in the months preceding Japan's December invasion. During the opening battles, some American and Filipino troops carried the new rifles, though many still relied on bolt-action Springfields. Early field reports revealed logistical problems. In certain cases, 5-round clips intended for older rifles were mistakenly issued, and improper maintenance in tropical humidity led to malfunctions. Soldiers also noted the rifle's weight during long jungle marches, yet in firefights the advantage became obvious. Units armed with Garands could generate suppressive fire strong enough to halt numerically superior Japanese assaults. Japanese troops, typically equipped with the Arisaka rifle, found themselves at a consistent disadvantage in sustained engagements. As American production accelerated through 1942 and 1943, distribution widened. By 1944, the Garand was standard issue across nearly all U.S. infantry divisions. It proved reliable in Pacific jungles, North African deserts, and European winters alike. German forces took careful note. By mid-war, it was increasingly clear that the widespread adoption of a reliable semi-automatic rifle had shifted the balance of infantry firepower in a way few had anticipated a decade earlier. During World War II, German officers frequently observed that U.S. infantry squads generated a noticeably heavier volume of rifle fire than comparable German formations, even though the Americans fielded fewer true automatic weapons. The reason was straightforward: the M1 Garand. Its semi-automatic design allowed every American rifleman to fire rapidly without manually cycling a bolt. By contrast, German troops relied primarily on bolt-action rifles, and their limited numbers of semi-automatic Gewehr 43 were typically issued only to selected specialists. In November 1942, Allied forces launched Operation Torch, landing in North Africa to open a new front against Axis forces. Among the assault units were British commandos assigned to operate closely with American formations, both No. 1 and No. 6 Commando were re-equipped with American small arms, including the Garand rifle, Thompson submachine guns, and Browning automatic rifles. They retained these weapons for the remainder of the war, favoring them over standard British infantry arms because of their durability, and the sheer firepower they provided under combat conditions. This preference proved critical in Southeast Asia. Late in 1944, No. 1 Commando joined 3 Commando Brigade in Burma, bringing their American rifles with them. By January 1945, they were fighting in the Arakan Peninsula, conducting amphibious maneuvers aimed at severing Japanese withdrawal routes. A key objective was Hill 170 near Kangaw, a commanding elevation overlooking the main road toward Rangoon. Counterattack. Artillery and machine gun fire hammered the northern slope of Hill 170, where Lieutenant George Knowland's No. 4 Troop defended its sector. At approximately 7:30 a.m., Japanese infantry advanced in successive platoon-sized elements, throwing grenades and charging with fixed bayonets. Knowland commanded only 24 men. They faced roughly 300 attackers, yet each commando carried a semi-automatic Garand. The tactical impact was immediate. Japanese soldiers, armed largely with bolt-action Type 99 rifles, had to pause between shots to cycle their weapons. The British defenders did not. Continuous aimed fire swept the hillside, cutting down assault waves before they could approach close enough to use grenades effectively. The fighting continued for nearly 12 hours. Repeated attacks pressed against the defensive perimeter. Knowland moved from position to position, redistributing ammunition, operating machine guns when crews were hit, and firing his own rifle until he was killed. His leadership, combined with the sustained firepower of his troop, prevented a breakthrough. By evening, more than 450 Japanese soldiers lay dead on the slopes. British losses were heavy, but did not collapse the defense. Hill 170 remained in Allied hands. Knowland was later awarded the Victoria Cross posthumously. The engagement became a frequently cited example of how superior small arms capability could offset severe numerical disadvantage. In miniature, it reflected a broader pattern seen across multiple theaters. Units equipped with the Garand could dominate firefights through sustained, accurate fire. Enemy assaults were disrupted before gaining momentum, and defensive lines could be maintained against larger formations. For a commander known for blunt criticism, the remark was notable. Patton understood that reliable infantry firepower enabled aggressive maneuver. When German forces counterattacked, American riflemen could deliver rapid defensive fire that broke up assaults and stabilized the line. Industrial production of the Garand matched its battlefield reputation. From 1937 to 1945, Springfield Armory produced 3,526,922 rifles. Winchester Repeating Arms Company added another 513,880. Total output surpassed 4 million by war's end. Factories operated around the clock in 3 shifts. By mid-1943, Springfield alone was turning out more than 4,000 rifles per day, despite wartime labor shortages that required women and older workers to replace those drafted into service. Quality control remained strict. Each rifle was required to group within 4 inches at 100 yards during acceptance testing. Manufacturing demanded precision. The Garand consisted of dozens of major components and hundreds of smaller parts, all built to exact tolerances. Barrels were inspected for alignment and bore dimensions, gas systems were pressure tested, receivers underwent stress evaluation to prevent cracking under prolonged use. This supply network spanned the United States. Steel originated in industrial centers in Pennsylvania and Ohio. Walnut stalks were cut from forests in California, Missouri, and the Appalachian region. The result was not only a technical achievement but a logistical one, an integrated national effort that delivered millions of reliable rifles to the front. Depended on a vast and highly organized industrial network across the United States. Precision machine tools were built in Connecticut and Massachusetts, while specialized spring manufacturers in Indiana supplied critical components. Tens of thousands of workers took part in this process. Most never saw a finished rifle. Instead, they focused on crafting individual parts that would later be assembled elsewhere. This distributed manufacturing system was not accidental. It was America's strategic strength. Shielded by the Atlantic and Pacific Oceans, U.S. factories operated largely beyond the reach of enemy bombers. As a result, American industry could replace weapons faster than adversaries could destroy them. While Germany struggled to ensure every infantryman carried sufficient small arms, the United States issued what many considered the most advanced standard infantry rifle of its time. The rifle did not come cheaply. In 1943, each M1 cost about $85, roughly $1,400 in modern currency. Producing 4 million rifles required $340 million. Yet when placed against America's total wartime spending of approximately $300 billion, this figure was relatively modest. The battlefield advantages the weapon provided more than justified the investment. After 1945, the rifle remained in frontline service for years. When war erupted on the Korean Peninsula in June 1950, production resumed at Springfield Armory. Two additional manufacturers, International Harvester and Harrington and Richardson, joined the effort during the conflict. However, at medium ranges, where much infantry fighting actually occurred, the M1's greater accuracy and more powerful cartridge proved decisive. Studies conducted after the war showed that most engagements happened within 300 yards, a distance at which the M1 performed exceptionally well. In 1957, the U.S. military adopted the M14 rifle as its new standard service weapon. Essentially an evolution of the earlier design, it retained the gas-operated system and rotating bolt pioneered by John Garand, while adding selective fire capability and a 20-round detachable magazine. Production began in 1959, and by the mid-1960s, the M1 had been fully withdrawn from active American service. Even when the M16 rifle replaced the M14, Garand's underlying engineering principles continued to shape American firearms design. International demand further underscored the rifle's reputation. More than 30 nations acquired American surplus stocks. Countries including South Korea, West Germany, Italy, Japan, Denmark, Greece, Turkey, and Iran issued the rifle during the 1950s and 1960s, with some keeping it in service into the 1980s. Its durability and consistent performance earned respect across continents. British troops who fought alongside Americans often favored the M1 over their own standard bolt-action rifle, the Lee-Enfield. Commandos who carried American weapons in North Africa and Burma maintained them long after the war ended. From the soldier to the mechanism itself, a distinctly 20th century solution, this technological philosophy mirrored America's broader approach to warfare. European powers often relied heavily on intensive training and long-standing traditions. The United States invested in industrial scale and mechanical innovation. Rather than depending solely on exceptional marksmanship, American planners sought to amplify the effectiveness of ordinary soldiers through superior equipment. In practical terms, this mattered enormously. A competent infantryman armed with an M1 could deliver sustained, accurate fire at a pace difficult for even a highly skilled soldier using a manually operated rifle to match. The semi-automatic system narrowed the performance gap between average and expert shooters. The arithmetic was stark. 3 British soldiers firing Lee-Enfields at a maximum sustainable rate of 15 aimed rounds per minute could collectively send 45 rounds downrange in 1 minute. A single American soldier firing an M1 at a moderate 24 aimed rounds per minute, below the rifle's potential, could deliver 40. Moreover, those 3 riflemen required 3 defensive positions and presented 3 separate targets. They consumed more food, ammunition, and logistical support. The mechanical advantage of semi-automatic fire did not merely increase output, it altered the balance between manpower and firepower. In that equation, technology decisively reshaped the battlefield. A single American rifleman armed with a semi-automatic weapon could generate nearly the same volume of fire as multiple soldiers equipped with traditional bolt-action rifles, while relying on far fewer personnel. Although the Americans fielded 2 additional soldiers, their advantage in firepower surpassed what 2 extra bolt-action rifles alone would have provided. This disparity reshaped battlefield tactics. U.S. infantry doctrine revolved around coordinated fire and maneuver. One element of a squad would pin the enemy down with continuous shooting, while another element advanced or flanked. The semi-automatic M1 made this approach practical. Its self-loading mechanism reduced interruptions for reloading, allowing riflemen to maintain steady pressure. An enemy forced to keep their heads down had little opportunity to respond effectively. British units faced a more complicated rhythm in combat. Because the Lee-Enfield required manual cycling after each shot, careful timing was necessary. Soldiers had to stagger their reloads deliberately to avoid moments when several rifles fell silent at once. Even with extensive marksmanship training, unavoidable pauses occurred when multiple men reloaded simultaneously. German forces encountered comparable constraints with the Karabiner 98K. Within Wehrmacht doctrine, the squad's primary striking power centered on the MG-34 or MG-42 machine gun, with riflemen serving largely in a supporting role. This structure proved formidable in defensive operations, yet it limited flexibility during offensive advances, where distributed rifle fire could be decisive. American formations operated differently. Every rifleman contributed substantial suppressive fire while moving forward, not just the automatic gunner. This broadened offensive capability and simplified coordination under pressure. The standardized armament that characterized U.S. forces. Japan pursued its own semi-automatic rifle programs, but development stalled before large-scale adoption. Industrial limitations and resource shortages hindered the mass production of complex self-loading systems. As a result, Japanese infantrymen typically entered combat with 5-round Arisaka bolt-action rifles. Against American units armed with semi-automatics, the imbalance in sustained firepower was stark. The influence of the M1 extended well beyond the Second World War. John Garand perfected a gas-operated rotating bolt system that became foundational in later military rifle design. Weapons such as the Soviet AK-47, the American M16, and the British SA-80 all incorporate variations of this operating principle. Although modern rifles often offer automatic fire, most combat engagements still rely primarily on semi-automatic mode for accuracy. The key innovation, allowing the weapon's mechanism to cycle automatically between shots rather than depending on manual operation, traces directly back to Garand's work during the interwar decades. His contribution altered infantry combat more profoundly than that of nearly any other firearms designer of the 20th century. Despite this impact, Garand did not gain personal wealth from his creation. As a government employee earning a modest annual salary, he declined to pursue a private patent, leaving ownership of the rifle entirely with the U.S. government. After the war, Congress considered awarding him a substantial monetary bonus, but the proposal did not pass. He received honors and medals, yet no financial reward reflecting the scale of his achievement. In 1953, at age 65, he retired from Springfield Armory after more than 3 decades dedicated to refining his design. They had armed American troops in 3 major conflicts, and their mechanical concepts shaped virtually every modern service rifle that followed. In contrast, Britain's decision to continue fielding the Lee-Enfield highlights how differing industrial capacities, strategic priorities, and national circumstances can lead to divergent paths in military technology. In 1940, United Kingdom stood on the edge of catastrophe. The possibility of a German landing was not theoretical, it was imminent. Under those circumstances, survival dictated every national decision. Factories, labor, raw materials, and currency reserves were all directed toward the single objective of endurance. Introducing a new standard-issue rifle at such a moment would have meant halting production lines, retraining workers, and disrupting output when time was the most precious commodity of all. Unlike the United States, Britain was responsible for a worldwide empire. Its forces were dispersed across Africa, Asia, the Middle East, and the Pacific. Replacing the service rifle would not have been a simple domestic adjustment. It would have required rearming units stationed on multiple continents. The logistical burden alone would have been staggering. Compounding the difficulty, British industry operated under constant threat. German bombing campaigns, especially during the Blitz, damaged factories, killed skilled workers, and fractured supply networks. Manufacturing capacity was already strained. Adopting a more complicated and expensive firearm design would have pushed that system beyond its limits. Became force multipliers. Across the Atlantic, circumstances were fundamentally different. Shielded by vast oceans, the United States faced no comparable threat to its industrial heartland. American factories operated at scale, free from sustained aerial bombardment. The nation's enormous productive capacity allowed it to absorb the cost and complexity of advanced weapon designs. Equipping every infantryman with a semi-automatic rifle was financially and industrially feasible. In practical terms, if American industry could build it, the U.S. military could field it. This strategic contrast helps explain broader patterns in the war. American forces deployed with more vehicles, more radios, more artillery pieces, and more aircraft, not merely because of doctrine, but because industrial output made abundance possible. The adoption of the M1 Garand was one manifestation of this larger reality. Designed by John Garand, the rifle embodied a shift from manual repetition to mechanical automation in infantry weapons. The practical difference was significant. A highly trained British rifleman might fire around 15 carefully aimed shots per minute with the Lee-Enfield. 3 such soldiers could theoretically deliver 45 rounds in that time. An American infantryman armed with an M1, firing at a conservative estimate of 24 aimed shots per minute, produced fewer total rounds than that trio, but he did so without breaking his firing position to operate a bolt. The rifle reloaded itself between shots, preserving sight alignment and reducing physical interruption. In sustained engagements, this consistency translated into steadier, more reliable firepower. Defensive positions required fewer men to generate comparable fire density. Enemy assaults could be disrupted by concentrated, continuous rifle fire. Technological leverage offset situations where numerical superiority was absent. The significance of the M1 did not go unnoticed. George S. Patton famously described it as the finest battle implement ever devised. The statement was less about perfection and more about transformation. The rifle represented a decisive break from tradition. The Lee-Enfield may have been the pinnacle of bolt-action refinement, accurate, durable, and fast by the standards of its type, but it remained bound to a manually operated system. No degree of training could eliminate the physical interruption required to cycle a bolt. The Garand's semi-automatic mechanism pointed toward the future. Within a generation, self-loading rifles became standard, and soon fully automatic infantry weapons would dominate military arsenals. The era of the bolt-action service rifle was drawing to a close, and Garand's design accelerated that transition. The rifle's legacy endures well beyond the Second World War. Surplus examples remain in civilian hands, distributed in large numbers by the civilian marksmanship program. Collectors value original wartime rifles for their craftsmanship and historical importance. In 2015, a Garand presented to John F. Kennedy sold for $149,500 at auction. 3 years later, Garand's own personal rifle, bearing serial number 1 million, fetched $287,500. Such figures reflect more than rarity. They underscore the weapon's symbolic place in military history. Had strengths, yet in the context of global industrialized warfare, America's capacity to innovate and mass-produce advanced equipment proved decisive. The contrast between the Lee-Enfield and the M1 Garand distills that difference. British soldiers were highly capable, and their rifle was an exceptional example of bolt-action engineering. But a self-loading mechanism fundamentally altered what an infantryman could achieve. Automation replaced manual effort. Consistency replaced interruption. In that shift lay a measurable increase in combat power. By the war's end, the direction of small arms development was unmistakable. Semi-automatic operation was no longer experimental. It was the new standard. The future of infantry combat had arrived, carried by American troops and chambered in .306.